day, everyone. Welcome once more to Insight Tutorials, the channel that gives you everything as regards academics and educational value. So my name is Peter Ogbaji. I'm your tutor for today. So today we're going to be looking at electricity. Another electricity, we're going to be covering electric charge, Coulomb's law. We're going to look at electric field and intensity. We're going to look at electric potentials, capacitance. We're going to look into current electricity. We're going to look into Ohm's law, resistance and resistivity. We're also going to be looking into circuits, both in series and in parallel. And lastly, we'll look at electric power. So we're going to start particularly with electric charge. And all of these, we're going to show you all the ways through which it could be tested, especially CBT-based exam and even theoretical exams. So let's start right away with electric charge. All right, so in continuation, like I said, we're going to actually start with electric charge. Now, what is an electric charge? An electric charge is simply the fundamental property of matter that causes it to experience force in an electromagnetic field. It is a source of all electrical phenomena you can ever think about. That's what we'll talk about, electric charge. I want to talk about electric charge. It's actually of two types. We have the negative charge and we have the positive charge. Of course, the positive charge is carried by proton and the negative charge is carried by the electron. And in terms of its laws, if they are like terms, they repel. That is to say, if you have positive and positive, in terms of its charge, it's going to repel each other by a certain amount of force. And if they are negative, it's going to repel each other by a certain kind of force when the charges are of the same sign, positive, or negative. But if they are negative and positive, if the charges are negative and positive, you see, if the charges are positive, they are going to repel each other. They are negative, they repel each other. But if they are negative or positive, they are going to attract each other. That's the law. And then electric charge has certain properties that you need to be very familiar with. And the first property of electric charge is what we refer to as quantization. And when we talk about quantization, the law of quantization actually states that electric charges are actually represented in discrete or fixed form and not in arbitrary value. So what that means is that charge only exists in multiples of the elementary charge. Now, what does that mean? When you want to deal with quantization, Q will be equals to NE. That is quantization. And this is a mathematical expression of quantization, where Q is the total charge, and it is measured in coulomb. And N is the number of electrons or protons. All right, and note it's always a positive integer. And the E is the elementary charge. And it has a constant value, which is 1.6 times 10 to the power of minus 19 coulomb. Now, remember we're dealing with the key properties. The key properties of electric charge. We're dealing with the key properties of electric charge, and the first one we'll talk about is quantization. Now, remember we say electric charge cannot be presented in arbitrary form, can only be presented in quanta. That means if you want to talk about electron, you either say it is one electron, which this N means the number of electron, right? You can either say it is 2 electron, where this N is the value for number of electron or proton. We cannot have electric charge as 1.5. We can't have it. We can't have it as 2.6, right? So it has to be a whole number fixed. Now let us look at the next property of electric charge. So the second property of electric charge, the second property is conservation. And this conservation state that electric charge can neither be created nor destroyed, but can be transferred, from one point to another, just like we have in energy cannot be created nor destroyed. So it's in that same manner. And then the third one I need to understand is the third property is the property of additivity. We state that the total charge is the algebraic sum of the individual charges. So what that means is that if I have one column and I have three column, and then I have four column, I'm going to say that their additivity is equal to the algebraic sum. So we're going to say it is 1 plus 3 plus 4. All in its column, it's going to give us 8 column. Sometimes we can have it as a negative, maybe negative and positive sometimes. In terms of additivity, you can have a negative charge in addition to another positive charge, and also let me see another positive charge. In terms of its additivity, remember this is negative. So if we're having 2 plus 3 minus 8, the additivity will be, this will give us a negative 3 column. So that means it's an electron, right? So the net charge is actually negative 3 column. You can also have it sometime where the positive can be greater than the negative, as the case may be. But if you have the additivity to be, let me say, they are positive, let me say 12 column minus, let me say negative 12 column as well. Now, this 12 minus 12 will give us 0 column. That means this is actually an electrically neutral charge. All right. It's neither tilting towards negative or positive. So it's electrically neutral. All right. So we're going to go into some key calculations as regards electric charge. All the calculations you need to know, the CBT pattern in which they can actually ask you quickly. All right, so like I said, we're going to do some CBT calculation, but before that, I'll need to guide you through some conversion process, because sometimes there are SI prefixes that are used for electric charge, and I just want to give you something in tabular form. So I'll give it in the form of so these are the SI prefixes used in electric charge. So the first of them, let's say this is the prefix, and then you have what we call the symbol. Then this should be the value. Now, let's start with this. Sometimes the basic unit of charge is coulomb, and if we have it as coulomb, the symbol is just C, and the value for that is 10 raised to the power of nothing. That's 10 raised to the power of 0. Now, there are times where they can give you your unit in kilocoulomb. If I say kilocoulomb, it means it is KC. That's what it means in symbol. And anything in kilo is 10 raised to the power of 3. Now, the next one they can ask you is your millicoulomb. Now, if they give you a value in milli, the word milli means negative 3, right? So you're going to say, if you see something like this, that is millicoulomb, and it means it is 10 raised to the power of negative 3 in terms of its coulomb. All right. Now, another one they can give you is what we refer to as the micro, because after milli, it is micro. And when you hear the word micro, what should come to your mind is something raised to the power of negative 6. All right. So we can have it as something in this manner. When you see this symbol, It means, let me make it fit. When you say this symbol, that's microcoulomb, and it is 10 raised to the power of the negative 6 in terms of its coulomb. Another one they can ask you is what referred to as your nanocoulomb. A nanocoulomb, you see like a small letter N and C added to it, that's nanocoulomb, and the word nano is 10 raised to the power of minus 9 coulomb. And if I'm to go further, I can talk about the picocoulomb, and it's a little p added to the coulomb, and that is 10 raised to the power of negative 12 coulomb. All right. Now, you can go as far as this is the last one. There's what we call the femtocoulomb. The femtocoulomb, and it's like a little f added to C, and that is 10 raised to the power of minus 15 coulomb. Now, the most used for exam purpose, it could be asked as long as electric charge is concerned, it's always the coulomb, and sometimes in millicoulomb, microcoulomb, or nanocoulomb. This is mostly used. On rare occasion, you see they use the picocoulomb or the femtocoulomb. Now that I know this conversion, so for example, if I give you two, this is, for example, what does this mean? This means 2 microcoulomb. So what you're going to do for you to convert it, because the unit of charge is not in microcoulomb, it's in coulomb, so you have to convert to the coulomb state. So you're going to simply do this number times microcoulomb means 10 raised to the power of minus 6. By this, it is converted to coulomb, so you can actually say it is 2 times 10 raised to the power of minus 6 coulomb. If I give you 5 NC, what does this mean? This means 5 nanocoulomb. So for you to do that, you're going to say 5 times, the word nano is 9. You're going to say 10 raised to the power of negative 9, and this is the converted state of nanocoulomb to coulomb. So that's how it works. So having known this now, we could go straight to solving some key things under electric charge quickly. All right, so we're going to go into solving some questions under electric charge now. So these are questions under electric charge. Now, remember that the formula for electric charge is the total charge is equal to N times E, where I say the Q is the total charge measured in coulomb, and the N is a number of proton or electron, which is always a positive integer. Like I said, electric charges cannot be in this fractional form. You can't have 1.5 electric charge. You have to have it in a quantized form. That means it has to be a whole number, and E is elementary charge, which is a constant of 1.6 times 10 to the power of minus 19 coulomb. Now, in terms of CBT exam, there are two major things that they will most likely ask you to find. You could be asked to find the total charge, or you could be asked to find the number of electron. Now, this number of electron or proton, it could either be negative or positive, all right? Now, electric charge is constant. On rare occasion, they can actually ask you to find the electric charge. So I'm going to categorize them in types. So the type 1 kind of questions you expect on electric charge is when you are asked to find the total charge. So we're going to go into a question right now on that particular aspect. So now, let's say we have a question like this. So the first type, I'm going to take you to 3 types. So there's type 1, and that type 1 is solving for the total charge, which is Q. Now the question goes, a body possesses 8 excess electrons. Calculate the total electric charge on the body. So from the question over here, we are told to find the total charge on this body that possesses 8 excess electrons. The formula that will aid us to do that is that the total charge is equal to the number, the positive integer, or the number of proton and electron times what? The elementary charge. Now, the question we're given that N is equal to, now, in terms of this number, we are giving electron, not proton. Take note of that. Electron. So that 8 excess electron, we'll write it as a negative. But before now, let's just write it as 8. electrons. And then the elementary charge is a constant 1.6 times 10 to the power of minus 19 coulomb. So our total charge is going to be it's going to be 8 times 1.6 times 10 to the power of minus 19 coulomb. And I'm going to actually punch that on my calculator. So having punched that on my calculator, I got my total charge to be 1.28 times 10 raised to the power of minus 18 coulomb. But this is our total charge will actually going to be a negative 1.28 times 10 raised to the power of minus 18 coulomb. Why? Because we are dealing with excess electron. Electrons are negatively charged, not positively charged. So that's the first. Then type 2 kind of question you'll be asked is to find the number. Type 2 type of typical question you could be asked in CBT in respect to this is solving for the number of electrons or protons. So we have a question like this under that category. A body carries a charge of 4.8 times 10 raised to the power of minus 19 coulomb. We're asked to calculate the number of electrons removed from the body. So in solving this question, we're still going to use a formula that Q is equal to NE. And in this case, we are given the total charge of this body. So the total charge of this body is 4.8 times 10 raised to the power of minus 19 coulomb. And remember that the elementary charge is a constant, is 1.6 times 10 to the power of minus 19 coulomb. And we're told to find the number of electrons that this body will possess. So we're going to make N the subject of the formula. So if Q equals to NE, we can also say that NE equals to Q, where N alone will be equals to Q all over E. So this is a constant formula. Anytime you are asked to look for number of electrons or proton, your N will always be Q all over E. So I'm going to make space here and solve this quickly. So what we have now, that N is equals to our total charge was given as 4.8 times 10 raised to the power of minus 19 coulomb all over our elementary charge is 1.6 times 10 raised to the power of minus 19 coulomb. So I'm going to actually punch this in my calculator. 4.8 times 10 raised to the power of minus 19 coulomb all over 1.6 times 10 raised to the power of minus 19 coulomb. So I have it that my number of electron that will be removed from this body is 3. It's 3 electrons. Notice that the number of electrons did not give us a fraction. It gave us a whole number. That's why it is said that in terms of charge, the charge is given in quanta in a fixed form. All right, it's a multiple integer, all right, of the elementary charge. So we have 3 electrons. Now the third part, or the third way they can actually test you in the CBT, which is very rare, but sometimes examiner can go into it, is to ask you to look for the elementary charge. All right, so I'm going to just give you a third type that through which question could be asked. Type 3. When you are asked solving for elementary charge. Now, there's a question under this. A body possesses a charge of 8 times 10 raised to the power of minus 19 coulomb due to 5 electrons. Find the elementary charge. Now, in respect to that question, we were given a total charge of 8.0 times 10 raised to the power of minus 19 coulomb, and we're given the number of electrons as these 5 electrons. We are asked to find our elementary charge. Now we should solve in such a way that we arrive at the constant. of 1.6 times 10 raised to the power of minus 19 coulomb, which is the constant for elementary charge. So we're going to say that, remember our formula that the total charge is equal to the number N times E, where we can say N is also Q, make E the subject to the formula, so E becomes Q all over N. In doing that, we substitute this value into that. So we have 8 times 10 raised to the power of minus 19 all over 5. So I'm going to type that in my calculator. 8 times 10 raised to the power of minus 19 all over 5. So it happens that my elementary charge is 1.6 times 10 to the power of minus 19 coulomb. So that is very, very important for you to note. Let's have another question with respect to that. A body possesses a charge of 8 microcoulomb. Calculate the number of electrons on the body. So what we're going to do in essence is that this body has a total charge. So when I say it possesses, that is to say it's microcoulomb. And we know that the elementary charge is 1.6 times 10 to the power of minus 19 coulomb. So we are asked to find M, which is the number of electrons that this particular body possesses. So the first we're going to do, we have to do a conversion on our total charge. You know that this is microcoulomb. So it's going to be 10 raised to the power of minus 6. So this is 8 times 10 raised to the power of minus 6 coulomb. So we've converted from microcoulomb to coulomb. So to find this, our total charge is N is, so N alone is going to be the total charge all over elementary charge, which is equals to 8 times 10 raised to the power of minus 6 all over 1.6 times 10 raised to the power of minus 19. So 8 times 10 raised to the power of minus 6 times 1.6 times 10 raised to the power of minus 19. It happens that we get our number of electrons to be 5 times 10 raised to the power of 13 raised to the power of 13 electrons. We'll do one more practice question. A charged particle has a charge of 64 nanocoulomb. Determine the number of electrons responsible for this charge. So with that question in mind, the total charge was given as, because our total charge is given as 64 nanocoulomb, and we are asked to look for our number of electrons that this particular body possesses. The elementary charge is still 1.6 times 10 to the power of minus 10 coulomb. Nanocoulomb, we need to do conversion. So when you hear the word nano, it means 10 raised to the power of negative 9. It's going to be 64 times 10 raised to the power of negative 9 coulomb. That's a conversion that we've done already. We can still go further to write this as 6.4 times 10 raised to the power of negative 8 coulomb. Because we know that if we are to write this in standard form, if we bring this backward in one way, it's going to be more like you're writing 6.4 times 10 raised to the power of 1 times 10 raised to the power of minus 9. And so if you do this multiplication, you're going to have this reduced to negative 8. So that's why it's like that. So we are looking for a number of electrons that this body possesses. So N is equals to 6.4 times 10 raised to the power of negative 8 coulomb all over 1.6 times 10 raised to the power of minus 19. So let us give out the value, because coulomb will cancel coulomb. If we have coulomb here, we have coulomb here. Coulomb will cancel coulomb. So what we'll be left with now is just electrons that we're looking out for. So do this on my calculator. 6.4 times 10 raised to the power of negative 8 all over 1.6 times 10 raised to the power of negative 19. So the number of electrons this body will possess is going to be 4 times 10 raised to the power of 11 electrons. That's going to be our answer. Thank you. I'm going to quickly run you through most tested CBT question in respect to electric charge. Number one, the question says, which of the following is the SI unit of electric charge? A says ampere, B says volt, C coulomb, D ohms. Based on the option that will be displayed on our screen, ampere is the SI unit for current, we all know, and then volt is the SI unit for voltage. And the last one, which is ohms, as option D, is the SI unit for electric resistance. The only correct option there is coulomb, of course. So coulomb is the SI unit for electric charge. Question 2 that you most likely be tested on. Question 2. A body gains 24 microcoulomb of charge. Determine the total charge on the body in coulombs. A plus 2.4 times 10 raised to the power of minus 5 coulomb. B minus 2.4 times 10 raised to the power of minus 5 coulomb. C plus 2.4 times 10 raised to the power of minus 6 coulomb. D minus 2.4 times 10 raised to the power of minus 6 coulomb. So we're going to solve this question right away. We all know that the total charge gained by this body, so it's more like you saying Q is equals to 24 microcoulomb. Now, one principle you need to understand is that anytime a body gains electron, it becomes negatively charged, right? And if a body loses electron, it becomes positively charged. So this question is going to be a negative of its answer. What we're going to do is to simply do a conversion, which is 24 times 10. Now we're going to convert microcoulomb to coulomb because our answer should be in coulomb. It's going to be 10 raised to the power of minus 6 coulomb. And if you write this in standard form, in one decimal place, it's going to be 2.4 times 10 raised to the power of, like you say, times 10 to the power of 1 times 10 raised to the power of minus 6. And if you do this, it's going to be 2.6 times 10 raised to the power of minus 5 coulomb. Now, since this particular body gained electrons, is going to become negatively charged. So our total charge that this body will possess is going to be minus 2.4 times 10 to the power of minus 5 coulomb, making option B the correct answer. Next. According to the principle of quantization of charge, electric charge exists A, in any fractional value, B, only in integral multiple of the elementary charge, C, only as positive charges, D, only as negative charge. We all know that according to the law of quantization, quantization is actually the integral multiple of the elementary charge. So other options are all wrong except option B, which says it is only integral multiple of the elementary charge. That's the correct option there. Next question. The principle of additivity of charge states that the total charge on a body is the A, product of all individual charges, B, difference between positive and negative charges only, C, algebraic sum of all individual charges, D, square of the individual charges. It happens that all the other options are wrong except option C. The law of additivity is simply the algebraic sum of the individual charges. So if we have Q1 equals to 2 microcoulomb, and let's say Q2 equals to 3 microcoulomb, we're going to get the additivity is simply the addition of the 2 microcoulomb plus the 3 microcoulomb, which will give us 5 microcoulomb. Except, of course, you're told to write it in coulomb and then you know the conversion to do. So that's the correct option. Next question says, a body becomes positively charged when it A, gains electron, B, gains proton, C, loses electron, and D, loses neutron. Now, looking at this, they say that a body becomes positively charged. So under what condition does a body become positively charged? It is when it loses electron. So the principle we must always understand is that once a body loses electron, it becomes positively charged. But when a body gains electron, it becomes negatively charged. Keep that principle in mind, very importantly. So the option that is correct is option C. Let's go to the next question. Which of the following statement about electric charge is correct? A. Electric charge can be created or destroyed. B. A body gains a positive charge by gaining electrons. C. Like charges attract while unlike charges repel. D. Electric charge is conserved. It can only be transferred from one body to another. What do you think is the right answer? I believe you should know before I even state it. So the correct option is option D. The first option that says that electric charge can be created or destroyed, that does not agree with one of the key principles or properties of electric charge, which state that electric charge can either be destroyed or created. It can only be what? Transferred from one body to another, right? And then second option that says that a body gains a positive charge by giving electrons. No, the moment a body gives out electrons, or if it gains, by gaining electron rather, if it gains electron, it becomes more electronegative. That means it becomes negatively charged. But if it gives electron, it becomes positively charged. So this option B contradicts it. So it's all not correct. Option C says like charges attract while unlike charges repel. It's opposite the law of electrostatic. You all know that like charges repel, it is unlike charges that attract. So making option D very correct. All right. Very importantly, I'm going to leave you with these 5 examination tips that you mustn't forget as long as you're dealing with electric charge. Number 1, if you're finding electric charge or you're finding total charge, use Q is equals to Ne. If you're asked to look for number of electrons or number of protons as the case may be, you should use N is equals to Q all over E. So number 3 idea that you must know is that if a body gains electron, it becomes negatively charged. Now, number 4, the same is true when it's opposite. If a body gains, if it becomes negatively charged, what do you think will happen if a body loses? It becomes more positively charged. So the fourth idea you must know is that if a body loses electrons, it becomes positively charged. And number 5 principle of model that is very important, always converts. So always converts from either microcoulomb or nanocoulomb towards coulomb. Very importantly, if you're given anything in microcoulomb, convert to or microcoulomb or nanocoulomb. When you see the word micro, just know it's 10 to the power of -6, nano is 10 to the power of -9, and then you must have converted it to coulomb. I hope this very video has helped you and you've learned so much as regards electric charge and its principle, its applications and calculations under them. The next series on the line under electricity you watch out for is Coulomb's law. Thank you very much for watching. Please subscribe, share and follow us on all tutorial updates, and always reach out to Insight Tutorials for quality educational guide. Thank you very much. I remain Peter Ogbaji, and nice having you around today. See you.